Hello, my name is Courtney Payne, Associate Editor at ASHRAE Journal. Thank you for joining us for today's webinar, part of the High Performance Building Supplier Webinar Series. The series provides information of interest to HPB readers and others about products and technology of interest to industry professionals. ASHRAE does not review supplier webinar presentations. The following presentation has been prepared by FacilityConneX on the subject, Finding a Balance, Establishing Cost-Effective Air Optimization and Enhanced Patient Safety. Today's speaker is Mark Pipher, Vice President and General Manager of FacilityConneX. Before joining FacilityConneX, Mark spent 8 years at GE as the General Manager of their Real-Time Operational Intelligence and Knowledge Services Division, where he helped drive their position as a market leader in the industrial internet space. Prior to GE, Mark was founder and vice president of engineering at Westridge Networks. Mark has also held executive-level roles at Celox Networks and at Motorola in their cable and networking business unit. Mark is a graduate of Rutgers University with a BS in electrical engineering. Mark, the microphone is all yours.
Thank you, Courtney. And so I'm going to start to talk through this whole concept of air optimization and what a facility engineer needs to do. But more importantly, we're going to identify use cases throughout the presentation that basically brings that to light. So let me talk a little bit about what I believe a facility engineer actually looks like every day. A facility engineer, to me, is like a trapeze artist. He has a lot of balancing that needs to occur between different situations across a hospital or healthcare environment. First things first, they tend to always bring safety as the first measurement of, even when a trapeze artist gets onto that wire, he always has to look at the safety nature of what's going on. And then when he thinks about the safety perspective, he brings in the whole concept of reliability, this whole idea that he has to keep the equipment and the processes running perfectly throughout the hospital. It drives not only patient safety, it also drives patient comfort. Real important to have those areas ready to go when they need to in these type of healthcare environments. And then lastly, they have to balance this other hand, the right hand of the trapeze artist, still has to maintain that balance of cost. And this is where they drive energy and efficiency. And when you think about this, this is a daunting task. Thousands of pieces of equipment built into a hospital that needs to be maintained by the facility engineer. And so what we're proposing here throughout this presentation, and we're going to prove it with real-life use cases, is the whole concept of balancing with monitoring-based commissioning system. And this is what people use every day when they drive attention to issues and challenges that they might have to face with the facility equipment. Best way to think about monitoring-based commissioning is looking at it from these block perspectives. And when you look at these blocks, you tend to focus your attention on what a monitoring-based commissioning system can do for you. First and foremost is the whole concept of environmental monitoring, in the sense of looking at air optimization, air pressure, balancing, equipment usage, exhaust in areas where there could be potential fumes, and then managing that with infectious disease control. The second block is about longevity of the equipment, being preventive and making that equipment more reliable over time, but more important, having visibility into that equipment if it's about to fail. And then lastly, believe it or not, the facility engineer drives revenue. He drives the bottom line because that's what energy conservation does for a hospital or healthcare, especially in these environments where revenues are down. Getting more dollars into the bottom line is a key initiative for anyone in the hospital itself without compromising patient safety or health. And then lastly, these bottom blocks are driven around things that a monitoring-based commissioning system helps accelerate in aspects of operational efficiency. How do you get information? How do you find out what the problem is? How long does it take to diagnose the problem? these are places where operational efficiency excels across with different aspects of the facility engineer. Of course, you have to always maintain this information, this data, so providing this on an as-needed basis in real time during a joint commission audit or any type of regulatory type process that you might have inside the healthcare is critical to keeping and maintaining the processes that you have. And then lastly, there's the ancillary effect of the fact that not only comfort, but people are more comfortable when they believe that the hospital healthcare has green initiatives and sustainability targets in mind. This all adds up to what we refer to as voices. This is the voice of your equipment, because this information comes from the equipment that facility engineer maintains every day. And by bringing this information together in a consolidated and well thought out process, it provides that balance that we're talking about that the trapeze artist does every day. So let me tell you a little bit about how this works. Simply put, you look at the yellow line. If you're familiar with what's been referred to as commissioning, either new or retro, that's the yellow type area that you're seeing on this chart. And what happens is that commissioning tends to happen sometimes on a 5 to 10 year basis. During that time, equipment actually drifts over time. It actually starts to degrade, things get changed, people make simple type measurement changes, new equipment is added, and there's no sense of balance or recommission that typically occurs every time you do that. So you get this little bit of drifting effect, but over time it really measures pretty heavily on the cost of running that equipment moving forward. But when you really look at it, you have BMS and BAS systems. That's that red area that sits on top. And these systems are well established and well used by the facility engineer. However, these type of environments are used mostly for the control aspects. You have to go and analyze that data, and you have to drive, with senior level people, the analysis that needs to occur. Well, what monitoring-based commissioning does, and it does every day, in real time, is this ongoing fault detection diagnostics. It acts a little bit like the guy who goes and analyzes the BMS data. It sits right on top of that system. It drives faults and fault detections, but more importantly, it predicts the actual failure, and more importantly, it actually tells you the cost of what it's costing you not to fix that problem. It's a very simple concept, but bringing that information together, you get back to that balancing. One other aspect that I want to make sure people realize a monitoring-based commissioning system does is two other things. One is its time to value is usually less than 30 days because it sits on the data and the sensor technology that you already have built in. It sits right on top of that information. It analyzes that data and performs exactly what you do in your head every day, or what a commissioning guy does to that piece of equipment when he goes and you pay for that commissioning. So typically for a system like this, because it's doing that for you and helping you get to bring things to resolution quicker, the payback on this type of system is 6 to 8 months. It's a really powerful type concept, and these systems do work every day. I'm going to show you some clear examples throughout the presentation that actually is driving these type of value story. One other thing that this type of system does also provide is it saves you money. Because what happens during this drifting effect I talked about earlier, things are basically wasting money. You're wasting energy, utilities are being wasted, and in these new days, you're going to be bringing in more outside air. That's why this presentation is focused on air optimization. But one concept I want you to think about throughout the presentation is how that facility engineer, when he actually makes a change and solves an issue that drives energy waste reduction, I want you to think about it from a revenue perspective, a healthcare revenue. Energy Star estimates that a healthcare environment has to bill out 20x for every dollar that the facility engineer saves. We are going to show you where we have saved that type of money with the facility engineer, working with them day in and day out, millions of dollars every year in the healthcare environments that we serve today with monitoring-based commissioning. First things first, let's talk about the safety aspects. Let's not alleviate. That's the #1 priority by anyone in a healthcare type environment is the patient safety, and that's including the facility guy who is basically going on the roof and fixing that air handling unit. It's a balancing act that needs to occur, but #1 is safety. So when you think about safety in facilities, and you focus your attention on those areas where things like infectious disease monitoring is occurring, you want to maintain things like positive air pressure. You want to balance that with temperature, humidity, and the cost of all these unbalanced areas. The sterilization areas, the labs, the pharmaceutical areas, these are places where you have to basically start to manage more of this positive air type environment. And you really want to focus your attention on systems that help you balance that. And that's what a monitoring-based commissioning system does. And typically in these type of specialized areas, the cost is higher, and there's a lot of pieces of equipment that contribute to that factor. So keeping the patient safe during an operating procedure, keeping the doctors basically comfortable as they're providing that type of procedure, keeping infectious disease out of the sterilization type areas is the #1 type aspect of areas where you want to have clear, real-time monitoring capability. And on top of that, you want to be alerted. You want to know if that is deviating at all during those conditions. Here's one example that I want to share with you. This is actually one of our customers, Lifespan, and we're actually monitoring 2 of their hospitals. One is Merriam Hospital. It's about a 500,000 square foot area. We actually monitor the whole thing. The beautiful thing about this is it was an extensions onto the hospital, so they have actually 2 BMS systems, 2 different ones, and so the facility engineer kind of has to know both of them. But having said that, a system like a monitoring-based type commissioning type system like ours tends to basically sit on top of both those BMSs and normalize that information for the facility engineer. Another advantage, because you're not going to forklift your BMS system out. It's too expensive to do that, and more importantly, you have people that understand those type of environments today. So we focused our attention in Merriam really around the commissioning of the HVA system, but more importantly, we started to also expand into the Rhode Island hospital. This is a 2.3 million square foot hospital. We're focused heavily on the air optimization and the process around operating rooms and sterilization areas. And this is going to be kind of focused on that topic. So I'm going to give you a cool example of what happens in Rhode Island Hospital today. And you're going to be very impressed with some of the concepts. But in these hospitals, we're doing over 500,000 checks a day. This is what those analytics, these real-time analytics that happen with monitoring-based commissioning is doing every day against all the equipment across both these hospitals. So let me give you a little bit of the air optimization story. This is one where we've had some balancing issues, and we saw, and this is just over this last month, guys, we saw over 3,000 annualized savings in 10 ORs by helping them maintain that balance. And they weren't off balance before. They started to get balanced when different things changed in the summer type environments, right? Because even as you walk through the seasons, temperatures, outside air temperatures and economizers are going to start kicking in into the fall. So you tend to actually see different aspects of the system. So having a system like this running in a real-time environment really gives you the assurance you need and watching these type of conditions. But check this out, guys. We every air handling specialized area that you monitor, you tend to have things like backup units. And typically you turn those backup units on from time to time. And when we turn the backup unit, when they turn the backup units, we were actually watching it on the monitoring-based commissioning system. And we saw the unit cause a simultaneous heating and cooling condition, and it basically ran for a few times over the month and added up to $8,700 in a single month. That's a huge amount of energy waste. Matter of fact, in this year alone, we've saved over almost close to $40,000 in energy savings. By the way, fixing that simultaneous heating and cooling was a quick 5-minute change on the BMS system. And now I'm saving $8,700 as the facility engineer in this environment. That $38,000 that we're saving right now is equivalent. Remember, I talked to you earlier about the fact that I want you to think about the equivalent. That facility engineer just brought in $770,000 in revenue to the bottom line. That's how these calculations occur. These are powerful stories with simple things. But check this out, guys. Look at the balancing across the 25 ORs in that one single building. It's called the Bridge Building. They're perfectly balanced right now. It's just amazing how these systems in real time keep that environment the way it needs to be. So let's talk about the second balancing act that the facility or trapezars, as I call them, needs to do. And it's all about reliability. Now we're getting into the equipment itself, not just the area like we just talked about and the safety of that patient that might be in that OR room. Let's talk about managing these thousands of pieces of equipment that can occur. And this is all about taking that zone and that zone area and translating it to the pieces of equipment and the components of that equipment that's making up that zone, that's feeding that zone its air supply. And so you start to ask questions like, how well is that air handling unit serving that zone? How well is your controls working? Well, your BMS is doing the controls, so how well is that working? Remember, we sit on top of those controls, those BMS systems. And then, is there any external situation that might be causing these issues? Are you basically having constant and variable type conditions? Are your dampers getting stuck, or worse, could you be leaking, basically fluid or water onto those filters, causing bacteria to form or mold to form on those units? You want to be aware of these type of situations. Monitoring-based commissioning systems make you aware of that. That's the question. Now, when you have all these issues, because God knows the facility engineer has thousands of issues on his plate to deal with, which ones do you focus your attention on? Well, this is where we help. Here's a great example of a customer, Southcoast Health, and they've been on our system since 2014, guys. So it's not like you basically find these issues in the first month and you fix them all and it goes away. These systems provide continuous return on investment, continuous type energy savings, years over years. And this is a great story with our friends at Southcoast Health. It's a little over 2 million square foot, 4 different hospitals, actually 3 hospitals and a cancer center, 4 different BMS systems that these guys have to manage too. These hospitals are about 40, 50 miles apart, so they're pretty hard for facility guys to kind of translate between. So they have 4 different teams using a single system to understand what's happening in HVAC, chillers, boilers, operating rooms, and more importantly, they use the system to export the data they need for joint commissioning. But let's look at a very specific condition. When you look at critical health and reporting, and you get down to managing these specialized areas, you want to understand what's happening on every piece of equipment that's in the process. And when you look at it from that perspective, you might be looking at 1 or 2 air handling units, but 50 VAVs, supply VAVs, and their exhaust. Maybe their exhaust is just running in a constant airflow type environment. Maybe it's actually controlled and variable in the way it runs. But there's so many different components on each one of these. Here's some great examples of ones that are detected above and beyond what your BMS or even individual can jump on and look at. I mean, can an individual come in and actually figure out what his air change rates from his BMS? Typically not. Typically, you bring in a certified air balancing company into your environment, and you do this once a year, maybe once every couple of years. And by that time, you've already wasted months of energy. So you want to do that kind of balancing like we talked about and focus. So we were looking at some of the ORs at one of the hospitals at Southcoast Health, and we're monitoring them for the air optimization, the balancing, and how well the controls are working. And we found the control problem on some of their supply and return VAVs, right? This problem added to $53,000 per year in annualized waste, energy waste. To fix this problem, it would cost Southcoast Health about $155,000. Now, that in itself is not a bad deal. That's a 1.5-year payoff on a particular situation in a critical area of the hospital. But we actually went, because we work with the utility companies, with our customers, and we spoke with the utility company about this situation, basically sent an application in for the energy conservation or getting an energy initiative, and the utility company is paying for some, if not all, of that $155,000 corrective action. And this is a great story on how you actually do the balancing. This is what a facility guy has to do every day. And this is going to make these units much more reliable. This is going to make this environment much more reliable and safe moving forward. And they're going to be able to maintain this year over year over year. And again, think about it from the revenue perspective. This single problem across several VAVs basically is going to save the hospital $1 million off the bottom line. That's what a facility engineer has done when you find these type of problems and solve them. This is a quote from the executive director, Christopher LeBlanc, about this. I mean, air quality is of utmost importance, he says. I'm going to leave this up for a second. You guys can read it. I'm not going to read it to you, but he says a monitoring-based commissioning, he's calling it the FacilityConneX platform, that his maintenance and energy teams use, are reducing costs by approximately 15%. These are big numbers, guys. 15% of your electrical bill. Think about that. Millions of dollars in electricity that is spent in a hospital. I'm going to talk about the ratio of how that is spent a little bit later in the presentation. Let's do the third thing, so make sure we have the full balance, because if you're not watching the other hand, you may lose your balance on this. And the other hand is all about cost. And the facility engineer has to worry about energy conservation as the third aspect. Remember, we're talking about healthcare, so patient safety, reliability of the areas, keeping them ready to go at all times is the top two priorities. But third is energy conservation. And you want to look at energy from the cost in these type of environments, from the cost of the outside air. Simply put, in healthcare, on average, if I increase the air change rate by 5 changes per hour, I am increasing that OR, depending upon its size, from $5,000 to $10,000. This isn't my data, guys. This is actual real measurements that occurred in studies out there by ASHRAE just recently last year. Okay. And then, when you really think about it, if you can actually change air change, maybe you're overrunning an area by 5 air changes. Over the year of running an area by over 5 could actually cause about $1 million in savings across the board because of the extra needs that need to acquire on heat and cool and humidification and even reheat. And all those aspects are brought together in a monitoring-based commissioning, so you only have to look at it from one perspective, and then it does a causal analysis to get you down to where you're wasting that money or where the problem is occurring. This is a great way, and with the new normal that is happening and pushing the fact that outside air needs to increase and air change rates are going to help drive less infectious disease from spreading, it becomes even a higher worry moving forward. because it's being targeted across hospital areas, not just in specialized areas anymore. They want to bring more outside air in all the areas. Even enterprise and office buildings are talking about these type of aspects. ASHRAE wrote new requirements around air change rates just recently and have created new guidelines around that. So there's a huge balancing aspect that the facility engineer has to really drive when it comes to safety and energy waste. Managing this is even more tougher because you have to manage it with the other aspects of pressure, humidity, temperature, and variations like that. And the strains on the support system people don't even think about. The chilled water system and the heating system that has to feed those areas when you readjust for more outside air. And in some of these specialized areas, it's 100% outside air coming in. So think about these things. I know you guys know about these things, but the balancing aspect is really crucial. And what tools do you have at your fingertips today, in your environment that you can use? Here's a great example, one more for you guys, Prisma Health. And Prisma Health is one of our great customers down in Greenville, South Carolina. We actually monitor 10 of their campuses. They have 2 Energy Star hospitals, and 3 hospitals have been awarded the Energy Care Award. And so these guys are focused. They believe in safety. They believe in the energy conservation story. One last point that I want to make around this before I talk about an actual finding here is the whole drive to having chiller plant efficiency and HVAC detection, because chiller plants drive HVAC behavior. The chilled water temperature, the balancing of a chilled water plant, how much that gets fed to your HVAC, how well your valves are running. These are all complicated situations that need to occur. Again, it's tough for the facility engineer to bring all those connections together. A monitoring-based commissioning system does that for you. So in Patewood Hospital, and you can see the note here, we have saved, this is the first campus that we went into, have saved over $1 million by deploying this type of software. You can see the BTUs that have been saved by that. More importantly, I wanted to focus my attention on actual cost here. And over those 10 campuses, we have saved over $2.5 million. This isn't my number. This is actually from Prisma Health, okay? This is a huge payback. Look at the quote from Mark Deese, who runs all the community facility. He's director of engineering for all the community facilities. It's actually about six campuses of the 10. And he talks about the challenge of departments to get capital money. So you want to put your money in certain places where you have big impact. And he talks about this type of solution as being a low-cost alternative to help you quickly and proactively fix things. It's really important to see what places like this is doing with a system and the impact it has on the facility engineer. Not to mention, not only does the facility engineer have the ability to use this system, the lower junior level technicians or the junior level facility engineer also has the capability of looking at these type things without the need of doing the analysis on the BMS system, because the system does it for you. So let me roll this up to actual revenue. All right, so when you look at $2.5 million saved, that's equivalent again to $50+ million in bottom line cost, guys. This is that profit line that your hospital does every day. The beautiful story here is the fact that these guys were engaged. They were going quick to fix issues and get those energy savings down. But more importantly, as the quote said, they were prioritizing things to the biggest impacts. Not just the biggest impacts for money, but the biggest impacts for safety and for equipment reliability as well. One other thing I want to point out to everyone on this webinar is the fact that, look at the charts. These are, this is from U.S. Energy Group, Information Administration. And you can see the use of HVAC, basically, and lighting. It's a combination of both. And it adds up to 72% of cooling, lighting, and ventilation. It accounts for 72% of the electricity. Now, I implore you today to think about your electrical bill and think about 72% of that bill, and then how it would look if you saved 15%. Let's say 10%. It's a huge number. And then multiply that by 20, because that's what Energy Star says, that if you can save that money for the hospital, $20 will have to go out as patient bills in order for you to make up that on the bottom line. It's a very simple concept, guys, and it's a powerful one. Okay? With that, I'm going to switch over to, looks like I got done a little bit earlier than I expected, about 5 minutes earlier. So I want to reiterate, number one, I want to thank everyone for attending this. We're going to do some questions now, so if you're willing to start to put some questions into the buckets there, or into the folders there. But let me point out a couple quick things. We have proven cases of patient comfort going up by 30%. We have specialized area reliability of that equipment, like I talked about, going up by 25%. And one of those hard to measure type of things is the efficiency. And we have customers who have told us that 20% increase in operational efficiency, and the junior engineer is able to act a little bit more like a principal level guy, looking at the information, organizing it in a much better way, and prioritizing it. And the time to resolution is up. So that's what's driving that patient comfort, or even that call rate down. Think about those type of ancillary effects that might be happening across that. And then more importantly, you don't do this and then let it just drift away again 5 years later. You do it with a real-time system that is constantly and ensuring that this is not going to happen again. Not going to happen in your healthcare on your watch. That's the way I think I would love for everyone on this call to think about this thing. Think about the effects of infectious disease monitoring and the pricelessness of causing something like that. And then dealing with these Joint Commission audits that come in from time to time, mostly by surprise, right? And how quickly you can get that data and form that report that proves that you have maintained that balance, that you have driven that balance across safety, reliability, and have maintained your process. And more importantly, for the business, you basically drove profit. You drove profit to the bottom line. So again, I thank you guys. Please, let's ask some questions now. I think Rhonda Landis, who is the Vice President of Operations in FacilityConneX, is going to monitor and ask some of these questions.
Okay. The first question that came in, impressive. Can this be adapted to facilities other than hospitals? For example, DOE energy laboratories.
Yes, that's a great question, and the answer is yes. Obviously, any place where there's facility equipment, it can be used and driven to provide the same type of results. Even in places where there's, even air optimization, the same type of analytics can be focused on that as well. And so, absolutely. You're going to drive energy savings. More importantly, you're going to drive reliability in those type of areas as well.
Next question. Are the savings you mentioned based upon projections or actual utility bills?
So the way our system works, and I can't speak to others, but the way our system works is we put your energy bills cost right into our system. So to answer your question, it's not built on any type of projections It's built on an actual real dollar amount that is sitting there on your bill. It's inputted into the system for that period of time that you're being charged that bill, and it can be basically done on different times of the day and different classifications. You can even have peak and normal times, I guess, is the way to say it. And so those are what the analytics use to basically determine it. We also only determine the energy waste when the problem's occurring. Keep in mind, problems don't only just occur and stay occurring. Lots of times, especially in the facility environment, it's an oscillating effect. Sometimes it's during the day, sometimes it's during the night. Once you're watching this 24/7, you might have missed that issue. So this system is watching 24/7. Matter of fact, my friends at Lifespan call it the 24/7 technician. That's what they call our system. Very cute name for it. Go ahead, Rhonda.
What type of data do you use to assess whether an area is imbalanced? And have you faced any issues with erratic zone pressure data?
Yep. Yes, and so just to give you a little idea, we basically take into effect not just the systems that might be associated with that equipment, like the air handling unit, the VAVs, the supply, any of the exhaust fans, and we take in all aspects of those type of environments, whatever's sitting in your data or capable of being censored. We also measure and look at design type aspects of the way the zone is worked, and we input those measurements into the calculation from time to time. And we take all that together, and the multivariable analysis algorithm that works there is looking at it based on the size of the zone or the area that it's serving, and they bring all those pieces together. We also bring in ancillary type systems, room pressure monitors, which are typically used in places like operating rooms and sterilization areas. And we bring that data in because we want to normalize it to the sensors that are happening. Because sometimes, guys, it's a sensor issue and not really an equipment failure. So we tend to basically watch those sensors. We manage the sensor health as aspects to telling you whether things are going wrong or things are going bad. Next question.
What is the average payback period using a monitoring-based commissioning system?
So the average that we have seen with across every industry that we do, not just healthcare, we have seen basically about a 6 to 8 month payback. It's usually a simple payback in the first year of the system. Now keep in mind, most of these type of systems are not just in place for the sake of just putting them there. They're usually a subscription-based type model. So you're going to be paying something year after year. But more importantly, with systems like this, especially when it's analytics and some great data that forms a picture of how your unit is running, in our type of environment in FacilityConneX, we provide what we call the FCX experience. It's a commissioning agent, a real live person, who talks with your facility engineers on a monthly basis and reviews the biggest actions to go after, the biggest corrections that might either be reliability issues, safety issues, or energy conservation issues. More importantly, you can see the system anytime, 7 by 24 by 365 days in real time. You'll get alerts and notifications, but it is important once in a while to basically have that human interaction and understanding, because you might want to fine tune or change some of the aspects of the system. So part of the analysis and part of the cost of a monitoring-based commissioning system is having that expert, energy and commissioning expert on staff for you.
And I'm going to read this one next just because it's actually very similar to what you just answered at the end of that last question. It says, thanks for a great presentation. How would the ECMs be authorized since the commissioning providers are recommending? Are you hiring engineers to look at the ECMs?
Yep, and so that's absolutely very similar to it. And what we do in FacilityConneX, and again, other products, monitoring-based commission products, companies might do it differently. I won't speak to those, but the way we do it is clearly that we believe in the concept of being your technical consultant. We believe in the concept of backing up our information, our savings, our findings that occur on our system on a month-by-month basis. It is important, just as it is important for you guys to maintain that balance, it's important for us to help you do that. And that's what FacilityConneX does, and that's why we have full-time staff commissioning agents that work with you and look at your system on a monthly basis and keeps driving that return on investment that we talk about every day. Yeah, Rhonda?
Yep, this is, again, just a follow-on question on the experience calls. Do you, based on your system's monitoring, provide recommendations on system upgrades or upgrades with variable speed capability for fans, pumps, and chillers?
And the answer is yes to that. And basically the biggest challenge that facility type departments actually face is balancing, the number of projects that they need to get done, right? And the cost associated with that, with those projects. And so when you have a system like a monitoring-based commissioning system, you basically start to see where those problems are actually costing you the exact amount of money. You're actually able to justify those better. But more importantly, it's about the prioritization of those things. And that's a little bit of what our system does. Sometimes you have to do a little further analysis, I think is where this question was going. And sometimes you have to look at, is it worth going in and basically upgrading or updating that system? In that example of Southcoast Health, after seeing the data and seeing some of the older units and how well they were running, we did an analysis with our customer, and we made decisions with our customer, not we, they did. They made decisions to actually replace 15 air handling units over a period of 2 years. They also got energy incentives from the utility company in order to do that. That was all tied to this very nice analysis of why it was going to be more effective and cost effective to either replace a piece of equipment, add some sensors, update the controls, and all that comes out in those monthly type meetings. These are bigger decisions and have to be planned in over the whole, years of working with our customers. Next question, Rhonda.
What are you using to normalize the BAS data from various manufacturers so that the analytics can run across all of them? Do you do the data normalization? If so, what's your average setup cost per square foot?
That's a great question. One of the things that, I'm surprised Rhonda just didn't answer it because this is what her and her team live every day. But the interesting thing is our deployments actually do the full normalization. So we actually don't care whether we're connected to a Siemens or Johnson Controls or an Andover Controls or even one of the older control systems. We've probably connected to 25, 30 different BMSs over the years we've been out there. We're very familiar with connectivity and what it takes. And the whole system, the beautiful thing about the system is it does normalize that for the facility engineer. It models it, it normalizes it, and we do that all in that deployment process I talked about earlier that happens in that first 30 days. Sometimes it's a simple process, and sometimes it's a little bit tougher, especially when some of the older type systems and no one really knows what different points or tags even mean. So it does depend on the environment that you have. But to answer your question, the cost, again, I won't speak. Some people actually have upfront costs to install a system like this. Other people like us in FacilityConneX, we tend to basically mold it right into our value story. So we're all about looking at that piece of equipment, all about providing optimization and value at the equipment. So we take in every piece of tag that we can find or every piece of data we can find, and we bring it in to effectively give you the best picture possible. That's an important aspect, and we basically don't ask you to really pay for the upfront. We tie it right into the subscription service for that piece of equipment. Next question.
How do we know if we have all the information that you need to do your analysis? Do we need to install a lot of new sensors to be able to get results?
We get asked that question all the time. And quite frankly, we have never, ever asked any of our customers to, and we're monitoring over 50,000 pieces of equipment today on our system. We have never asked our customers to put more sensors in. We use the data that you have. We use the sensors and the information that you can get. We complement that information with design considerations that get inputted into the analytics, and we give you the best picture. Now, the more data, the more sensor. I'm not going to kid you guys. The more data, the more sensors, the better causal analysis you get. You could even get down to root cause if you have all the data there. But we basically take our analytics and we run them at the best possible points and data that you have. And then we basically form that picture and we give you a probability analysis in real time of what is actually happening and what's occurring. Okay. Next question.
Are you using tritium JACEs to bring in points for analysis?
We do. We've connected to tritium JACE. Matter of fact, we have, I want to say 3 of one of our customers actually out there, maybe a little more than that now. But 3 of our connected buildings are using tritium JACE, so we do bring data. Typically what happens with tritium JACE, because it's a beautiful control product that's out there today that uses, and it usually translates right to BACnet protocol. BACnet is a standard BMS type environment that everyone seems to have. And that BACnet protocol just gives us the data. We act like a BACnet client, so we just basically get the data right from that JACE tritium type environment. Having said that, we do have other types of systems, I won't mention names, that basically need the ability, can't really support the BACnet type protocol, or can't support the network associated with bringing that data up into our system. In those type of cases, we have a very nice way we do it with a file export type system where the data is basically sent to us on a more periodic basis, hour, 4-hour type basis, and the analytics will run over that data and over that time period and still provide you results. Sometimes those results will be within the time frame when you clicked on the screen. Sometimes it could be as little as 4 hours behind. But more importantly, you're still getting these results. It doesn't matter what type of data it is. Next question.
We need to have hard copies of this type of information. Is that possible with your solution?
Absolutely. It's an age-old problem that people still need to have paper copies, especially in these regulatory type environments. And you could export. You can do it really 2 or 3 different ways, to be honest. In our system, you can do it with a simple reporting type push. You can actually export the data into a spreadsheet that you might be using and analyze and use that data effectively. You can even go all the way down to the raw data and get your raw data results and do your own analysis as well. Our system also provides the ability for you to create custom views that you can export into reports or see in real time those type of environments. So any platform that is a monitoring-based commissioning platform should be providing this type of technology and user interface for you. Next question.
What type of algorithms do you use for chiller plants and chiller plant optimization?
That's a longer question, I guess. I'll try to answer it generally, but if you want to find out more information about our chillers, please just reach out to us through our website. You can see it right there, and we'll have a demo of the chiller detailed analytics anytime you want. But just to answer your question, we tend to, with chiller plants and even chilled water systems, we typically don't go through the BMS system. The way that we look at really chiller plants is we go right to that controller. We are connectivity experts. We have over 200 protocols, so we can even go down to the PLC or the actual SCADA. You might actually have an HMI SCADA type product managing your chilled water system. We've seen it all, so to speak, at the chilled water environment. So, and the nice thing about that is typically when you go up in the chilled water plant and looking at optimization, you have to see all those aspects of the chiller plant. And we do everything from not just looking at the mechanical aspects of the compressors, the chilled water loops, the cooling towers, all associated with that chilled plant. We also bring all those pieces together. We do energy analysis on it. And more importantly, we look at the optimization that needs to occur at the plant level. And when we have the HVAC being tied to that chilled water plant, we're showing you both sides of the process. Upstream to the air handling unit, you know, how well the plant is actually serving that. And the nice thing is in those monthly calls, we might even talk about how you adjust the temperature in your chilled water plant to gain efficiency at your HVAC unit. How often do a facility engineer get the time to even think about things like that? So that's a great question. And again, I encourage you to reach out to us. We're more than willing to go through a lot more detail around the algorithms. Next question. Any more questions?
Yeah, just a couple more. How do you compare energy use across different size buildings, or, you know, the EUI?
So we have an energy component in our system with our monitoring-based commissioning system that brings in energy consumption and analysis. And we have components that look at interval data, including the metering information, but more importantly, we do virtual metering down to the equipment. And the way we look at and normalize that information is we normalize it either based on kilowatts, square footage. We even normalize it based on the utility itself. If you're looking at calculating things or having a real-time calculation of carbon footprint, like in places where you have local laws where you have to reduce your carbon footprint, we have these all built into our energy views for you to use, so you can track them and see them in real time. And more importantly, they're normalized, so you can actually aggregate every building in your campus or every building and compare them. And you can see which ones are your and so you want to compare those by time. We give you the ways to do that all the way up to roll-ups, right, from the building envelope all the way down to the actual piece of equipment and its type. Next question.
You want to repeat that last one?
Sure, I'll repeat it. Sorry about that.
Yeah, thank you.
Can you repeat the question, please?
This one was the energy use, the energy use comparison. Yeah.
Yep.
How do you compare energy?
Yeah, and so, yeah. And what I said was the energy in our system, and again, I won't talk about other monitoring-based commissioning systems. We have actually a component called energy that actually drives the energy perspective from a consumption and peak demand type basis. The important thing around that is our energy consumption not only looks at the higher envelope of the building itself and compares those buildings and normalizes that to either kilowatts or square footage or type of building. We also drill down to the usage based on equipment. And you don't necessarily have to have physical meters at those levels to see that. We have a virtual metering concept. I already talked about the fact that we actually estimate the energy waste that's occurring to help you prioritize these findings earlier in the presentation. We use that same technology and flip it, right? We use it and flip it and say, this is what that unit is consuming. So you can actually virtually see different types of air handling units or even air handling units around similar types. And you can focus on which air handling units of similar type are actually consuming the most energy. So you have all those aspects from the building envelope to the total campus, all the way down to the piece of equipment. We have customers that do it down to the terminal device. the actual supply VAV. And it gives them perspectives of how well they're serving that area. But more importantly, they can look at it across all those terminal devices, hundreds of them, all at the same time in one single view. And it's a really nice concept because you can see which ones are underperforming as well. And it's a real nice way to get quick to places where you might have potential patient comfort issues. Next question.
You need lots of different people to access and view this information for various reasons. Do you charge by the number of users?
So we always have, since our start, not focused at all on the users. There's really, to us, one aspect and one aspect only that we're basically providing to you. We're going to basically manage your equipment. We're going to manage the process and optimize it to cost. So our pricing is all around that piece of equipment. We don't charge for users because we want adoption across all the functions, everything from your facility engineer to the director of facilities up to the energy management people, and more importantly, even some of the ancillary people like the infectious disease, people that want to monitor how things are going, or the joint commissioning reports that people put together. All that is basically, so we give you unlimited users. But more importantly, we don't focus on the data, the amount of data anyone needs to provide us. We want it all. We want you to give us your data. That's really important to us because that allows the analytic to basically give you the causal analysis that gets you to go faster to fix these problems. That's the important part of this equation. So we do not charge for any users. Rhonda?
Is there a general rule of thumb that can be utilized for budgeting implementation costs for this type of system?
Yeah, so there's really two ways to think about the pricing of a system like this. Again, it's based on the number of pieces of equipment or the areas it serves. A lot of people start with a certain area or problem area that they really want to focus on, whether it be a chilled water plant, or maybe it's the ORs, like the examples I gave you. Most people don't start with the whole envelope. But just to give you guys a little feeling of the cost associated with that, when you're looking at everything from a terminal device to an air handling unit, you're probably looking somewhere between $50 a year to $1,000 a year, depending upon the size or the complexity of that unit. When you're looking at it on a per square foot basis, think about somewhere around the 12 to 15 cents a square foot is where you probably are when you're doing a single type building. As you go and do much wider and larger buildings, over 1 million square feet of space, your price goes down from there. Okay.
Andy, I think I'm going to flip it back to Austin at this point. The last question, which there were a few of them, was basically about how do we get the presentation?
Maybe that's for Austin to answer.
Right. Hi, this is Austin Bradford from ASHRAE. An email will be going out to attendees tomorrow with a link to recording the presentation. As for obtaining the slides, Mark, I would recommend people contact you. Would you like to provide your contact information?
Yep, I can do that. Yep. And again, you can contact us through our website, or you can contact me directly at Pipher, Pipher, at FacilityConneX.com. Okay. Anything else, Austin? Do you want to close it out?
Nope, I believe we are good. Thank you, everyone, for attending today.
Thank you, and have a great day.